So, you've probably noticed AI is getting ridiculously smart, like scary smart and fast. Ever wonder how? Well, a huge piece of that puzzle is this game-changing idea called self-supervised learning. Today, we're going to pull back the curtain and see exactly how AI is starting to teach itself.
Okay, so let's start with a big question, a real mind bender. What if, what if AI could teach itself? I mean, really teach itself, without a human looking over its shoulder, without a teacher grading its homework. This isn't some far-off sci-fi concept. Nope. This is happening right now, and it's the single idea that's flipping the entire world of AI on its head.
To really get why this is such a revolution, you gotta see the before and after. On one side, you have the old school method, supervised learning. Think of this as the AI needing a human teacher for everything. Every photo, every sentence, meticulously labeled by hand. It's just painfully slow and wildly expensive. But on the other side, that's self-supervised learning. Here, the data itself becomes the teacher. It's fast, it's scalable, and it basically gives AI a library card to the entire internet. All right, so before we dive deep into the solution, let's talk about the problem, because it was a huge one. For the longest time, AI had this massive bottleneck, this one thing holding it back. It was completely dependent on us, on a human teacher. So what's the problem? In two words, data labeling. The old way of doing things meant that for an AI to learn, humans had to spoon-feed it information. We had to label millions upon millions of images. This is a cat. This is a car. Think about this. It's like asking a librarian to read every single book in the world and write a little sticky note summary for each one. The scale is just insane. It costs millions, it can take years, and when you get to expert stuff like asking top surgeons to label medical images, forget about it. It's just impossible at scale. Yeah, that data labeling bottleneck was a real wall. The field was hitting its limits. And that's exactly why we needed a breakthrough. And boy, did we get one. Enter the elegant solution, machines that could finally teach themselves. So what's the secret sauce here? It's a clever little concept called a pretext task. And honestly, it's brilliant. Just think of it like the AI creating its own puzzles to solve, using the data it already has. So instead of us telling it, this is a cat, the AI will take a sentence like, the cat sat on the, and just hide the last word. Its job, its pretext task, is to figure out the missing word is mat. Now, do that a billion times, and it starts to learn the rules of language, context, all of it, without any human help.
And let's be clear, this isn't just some tiny tweak. This is a game changer. Why? Because it suddenly unlocks the entire internet as a textbook for AI. All that unlabeled data we couldn't use before, it's now fair game. This means the models learn much deeper, more flexible ideas about the world. They get smarter, they can generalize better, and the best part? This trick works for everything. Text, images, audio, video, the whole shebang. Okay, so how does an AI actually pull this off? Well, it's not just one magic trick. It's more like a whole playbook of strategies. Let's open it up and look at the four main plays that these AIs run to teach themselves. First up, the big one. This is probably the most popular and powerful strategy out there. It's called contrastive learning. And what I love about it is how simple the core idea is. Ready? The AI just learns to tell the difference between what's similar and what's, well, different. It's basically a giant superpowered game of spot the difference for machines. So here's how that game works in practice. The AI grabs an image, let's say a picture of a cat. Then it creates two tweaked versions of that same picture. Maybe it crops one and messes with the colors on the other. The goal is to teach the AI that these two images, these positives, are basically the same thing. Then it throws in a negative example, like a picture of a dog, and its job is to learn to push that dog picture away, to say, nope, that's different. You do this millions and millions of times, and the AI starts to build an internal concept of what cat means, just by playing this simple game of compare and contrast. All right, so that was strategy number one. Strategy number two is called predictive learning. Remember that fill-in-the-blanks idea we mentioned earlier? This is pretty much it. You take an image, but you black out a random square of it. Then you ask the AI, hey, what's supposed to go here? To get it right, the AI has no choice but to learn about textures, shapes, and the underlying structure of the visual world.
Strategy 3, generative learning, kind of takes that idea and puts it on steroids. Instead of just filling in one blank, the AI gets a really messed up version of something, like a super blurry, low-res photo, and its job is to reconstruct the original, high-quality image. Think about it. To be able to do that, it has to have a really deep understanding of what things are supposed to look like. It's learning by rebuilding.
And that brings us to our fourth and final strategy, clustering-based learning. This one's pretty cool. Imagine you dump a giant box of mixed-up Legos in front of the AI. With clustering, the AI's job is to start sorting them into piles. All the red bricks here, all the blue ones there, all the little window pieces over here. It creates its own categories, its own clusters. Then it uses those self-made labels, we call them pseudo-labels, to teach itself even more. It's basically inventing its own organization system for all the data it sees.
So there's our playbook. Let's do a quick recap. We have contrastive learning, which is like spot the difference. Predictive learning, that's our fill in the blanks. Generative learning is all about rebuilding a puzzle. And clustering is like sorting by category. 4 different strategies, but they all have the same incredible goal, letting an AI build its own curriculum from scratch using nothing but raw data. Okay, this all sounds pretty cool in theory, right? But this isn't just some abstract idea stuck in a research paper. This stuff is out in the wild. Let's talk about how self-supervised learning is already changing our world and powering the tech you probably used 5 minutes ago. I mean, seriously, every time you type something into a search engine or interact with a modern chatbot, you're seeing SSL in action. Google's big language model, BERT, it learned to understand what you're actually asking for by playing that fill-in-the-blanks game billions of times. The same goes for models like GPT-3, which write stunningly human-like text just by predicting the next word. And here's the crazy part. Nobody ever explicitly taught them the rules of grammar. They just figured it out. And it's not just about language. The same revolution is happening with what AI can see and hear. You've got computer vision models that can spot objects in photos with pinpoint accuracy. That's huge for self-driving cars, but also for things like helping a doctor find tumors on an MRI scan. And in speech recognition, models are learning to understand what we're saying directly from the sound waves, which is why your smart assistant is getting so much better at understanding you, no matter your accent. So, what's next? Where is all this heading? Well, the future of AI is definitely self-taught. But, it's not all smooth sailing. There are still some big challenges to tackle, but also some absolutely mind-blowing possibilities on the horizon. Okay, let's get real for a second. It's not a perfect system yet. Designing the right kind of puzzle for the AI to solve is super hard. If you pick the wrong one, the AI learns a bunch of useless trivia. And maybe the biggest issue right now? The cost. Training these models requires a mind-boggling amount of computer power, which costs a fortune and uses a ton of energy. But the future here is just so exciting. We're on the verge of creating these unified models, a single AI that can understand text, see images, and hear audio all at the same time, weaving it all together just like our brains do. We're getting closer to AIs that can solve a new problem with just 1 or 2 examples, or maybe even none at all. And a huge focus right now is making all this power more efficient. So it's not just for the big tech companies, but accessible to researchers and creators everywhere. When you step back and look at the big picture, it's really hard to overstate how big of a deal this is. I think this quote really nails it. The era of machines teaching themselves has arrived, and it is redefining the boundaries of what artificial intelligence can achieve. That's it right there. The boundaries are being redrawn. And that leaves us with one final thought, something to really chew on. When our AI is finally, truly free from the bottleneck of needing a human teacher, when it can learn on its own, what problems that we think are impossible today are we finally going to solve? What breakthroughs in science, in medicine, in everything are waiting just around the corner?